All right, here we are, ready for definite integration. Okay, so before I get to the actual how to find definite integral stuff, I want to get through some of the rules of definite integration. So last video I talked about Riemann sums and about the notation of this. So if we integrate from A to B from bottom to top, that's just how much of the curve we're trying to cover in terms of the width. So in order, the integration does matter. Okay, so if you look at this, we go integrate from B to A and then flip it from A to B, we have to negate our integration here, okay? And again, if you look right here, this is kind of more of our more basic, what everything looks like. Again, integral sign is kind of looks like an S. It's a really, really stretched S. Lower limit's the bottom one, upper limit's the upper one. The integrand is the function inside. And then the dx, the x is the variable of integration. All right. So if we have a width of 0, think about a rectangle with a width of 0. That's going to give us 0. All right. If we have a constant, we can always just pull out the constant, whether it's just a k or a negative. You can split up integrals into two different functions, or you can even split up the bounds itself. So from a to b and then from b to c is the same thing from a to c. Okay. So let's talk about some real quick things about functions and integrals. So if we have a function that's even, think about just the most simplest even function you know, like a parabola, like this. So here is a parabola. So we have a function is even on the y-axis, and we're integrating from, just say from here to here, from negative a to a, so it's the same width on both sides. It's actually going to be the same thing as doubling it and going from 0 to a of f of x dx. So that's important to know, because that can be really helpful. We're just trying to think of little tricks right now just to give you a little helpful on this. Now, if we have an odd function, like a cubic, so a cubic is odd, we're integrating from negative a to a. Since now you can have a negative area, what's going to end up happening here is the negative area and the positive area are going to end up canceling out, and we're going to be left with a big old 0. Okay, because integration is really just finding area. So for Riemann sums, we just found all the areas of all the rectangles. For this type of stuff, the integral is finding the actual area underneath the curve. Okay, so let's use these rules over here and start to kind of go through here, right? So we have f of x is even, and from 0 to 5 is 3. So what's from negative 5 to 5? Well, that's the same thing as saying, since it's even, it's just going to be double, because we're going from negative 5 to 5. So this would give us an answer of 6. Okay? Same thing. Since it's even, these are actually equal. This is the same thing as from 0 to 5, f of x dx, which is 3. And for this one, well, I just did this answer up here, didn't I? But this is going to be equal to 4 times that from negative 5 to 5 of this f of x dx, which we found was 6. So it's going to be 6 times 4, which is a 24. Now let's start working on some problems where they're odd. So say the function is odd, and then the one side of it from 0 to 5 is 3. Well, if it's odd, and we're integrating from one side to the other, it's the same width, so if it's from negative 5 to 5, that's actually going to give me a 0. This one's a little bit trickier now. This is odd, so from negative 5 to 0 is actually going to be, since this is positive, it's going to be opposite here, negative 3, because it's on the other side of the y-axis. So then from negative 5 to 5, 4 times that, well, this would just be 4 times negative 5 to 5 of f of x dx, which is 4 times 0, which is 0. All right. So those are just the most basic rules. Now we're going to actually get into some problems of the integration. Now, for those of you that have taken AB before, know that there's some formulas you can use. This entire class, I'm just going to try to use geometry, because geometry is the easiest way to find any of these integrals. I promise you. It's the easiest way. So if you can ever use geometry to figure these out, use geometry. Trust me. So if I have a function of 4, this is the function for right here. But I want to integrate from 1 to 6. So this is from 1 to 6. I'm trying to find the area underneath this 4 from 1 to 6. What shape does this make? This makes a rectangle. So it's got a rectangle of a width of 5 times a height of 4. So it's just 5 times 4, which is going to give me a 20. So we're just using geometry in all these. Okay? X plus 2. So we'll go ahead and draw this a little bit. 1, 2. So this starts here. It goes here. It goes here. And we go all the way out to 3. And it goes here. So here's my function. Now I'm just going from 1 to 3. So that's right here. What shape does this make? It makes a trapezoid. And I talked about this in my Riemann sums. So a trapezoid is just going to be 1/2 of the average heights here. So what are these heights? Well, 1, 2, 3 plus 1, 2, 3, 4, 5 times the width of my base, which is a 2. So this is going to be an answer of 8. Just using geometry. Now this guy right here, it's really helpful to know what this is, okay? Because this is a geometric shape, believe it or not. You just need to know which one it is. Because when we start learning formulas, it is still really hard to integrate this, even with formulas. So if you ever see something like this, it's really nice just to know shapes. So this is actually going to be a semicircle. So you have y squared plus x squared equals radius squared. So that's how I know this, is because I have this y squared, I'm subtracting it over here, and this is my radius squared. So my radius is actually 2. So I have this right here. So my radius is 2, and this is a semicircle because it's only one of these, right? Because you take the square root, you get a plus and a minus. This is just the plus. It's half of the circle. So this is a semicircle. Okay, so the area of a semicircle is 1/2 of pi r squared. In this case, we get 2 squared. So this answer is just going to be a 2 pi. All right. And this right down here, we're just going to add up all of our little shapes right here for geometry. So we're going to go from -4, which is right here, all the way out to 4, which is right here. So what you're going to do is you're going to find the area of each of these shapes, and then you're going to add them all together. So let's go ahead and do that. So this is a triangle with a height of 2 and a width of 3. So that's going to be 1/2 times 3 times 2, which is 3. So the area of that is 3, but since it's below the x-axis, it's actually going to be a -3. I'm going to color code this for you. So it's going to be a -3. This triangle right here has a base of 3, so it's 1/2 times 3 and the height of 3, which is going to give me 9 halves. So I'm going to do that in 9 halves. And then this triangle right down here, so 1/2 times 2 times 1, which is going to give me an area of, where the heck did I put my red? I must put it away. Red is -1. So if I add all these together, I'm going to get -3 plus -1, which is -4, plus 9 halves. And -4 plus 9 halves is, well, it takes a little bit of math here, but this is actually going to give me a positive 1/2. Okay. All right. So we're given these, which is super nice, is we have the integral from 0 to 3 of f of x is 4. integral from 1 to 4. Oh, nope, this is a different problem. We have integral from 3 to 7 of f of x is negative 1. We're going to go ahead and find all of these. So integral from 5 to 5. Now, anytime you have a base of 0, your answer is just going to be a 0. It's a rule. Integrate from 5 to 5. Your width is 0. Okay, so from 0 to 7, that's the same thing as adding these two together, because this goes from 0 to 3. It's the same thing as from going 0 to 3 of f of x dx plus 3 to 7 of f of x dx. So we're going to add these together. 4 plus negative 1, which is a 3. And then from 3 to 7, we already know this. This is the same thing as 2 times the integral from 3 to 7 of f of x dx, which is going to give me 2 times negative 1, which is negative 2. And now looking at my last problem here, is we have y minus 1. So if you notice now, we're integrating with respect to y. So that's important to know. So let me go ahead and draw this real quick. Okay, so this is y minus 1. That's important to know. So this is the same thing as x equals y minus 1. So this is the same thing as x plus 1 equals y. So that really helps for me for just graphing it. But now, since I'm in terms of y, it's integrating from a height of 1, which is right here, to a height of 4, because this is all in terms of y. Okay, so I'm integrating this right here, this area. No need to change bounds or anything weird like that, because this is just geometry. It is a triangle here, so this is going to be 1/2 times the height times the base, or it doesn't really matter, is going to give me 9/2. All right, and that is how you can use integration, by using geometry. Much easier. It's the easiest method to do is just use basic geometry. We will be learning formulas that go along with this, and we will tackle that